R equal to R naught into 1 plus alpha T. Mercury at 4.2 K is act as a superconductor. Ceramics, the most surprising discovery was that ceramics which are insulators exhibit superconductivity at as high as 100 K temperature. The superconductors properties, zero resistance and infinite conductance, they are perfect diametrics with susceptibility of -1. When they are placed in a magnetic field, they expel completely the magnetic lines of force, and this is called Meissner effect. They possess a critical temperature above which they become normal conductors, and below which they remain superconductivity. Mercury at 4.2 K acts as a superconductor. Superconductor can be destroyed with the application of external magnetic field, and is called as critical magnetic field. Applications of superconductors: electrical power systems and devices such as power transmission lines, electrical motors and transformers, sensitive superconducting quantum interference devices, SQID sensors, ultra-fast superconducting digital logic components, in addition to cryotron switching devices and superconducting magnetics. In addition to cryotron switching devices and superconducting materials, this logic component produces very large magnetic field. Maglev trains, these are transport vehicles such as trains which can be made to float on strong superconducting magnetics, virtually eliminating friction between the train and the tracks using magnetic levitation technology. The compounded 3, 4, 3, 5 elements are boron, nitrogen, aluminum, phosphorus, gallium arsenic, indium antimony. Among these, gallium arsenide is extensive use in semiconductor industry. It has a band gap of 1.43 electron volts. Similarly, the compound 2 to 6 group elements compounds also exhibit semiconducting properties. 2 to 6 group elements include CDS, CDSE, and CDTE. They have energy gaps of 2.45 electron volts, 1.47 electron volts, and 1.45 electron volts respectively. As we need different band gap values to suit different applications, there we go for alloy semiconductors. GAPX, AS1 minus X, GA1 minus X, ALY, PX, AS1 minus X. By varying the values of X and Y, we can get different band gaps. Semiconductors for visible LED used in a display system requires a band gap of the range of 2 to 3.2 electron volts. The infrared LED used in remote controls need a band gap in the range of 1 electron volt to 1.6 electron volts. The thumb rule for band gap in electron volts equal to 12,400 by lambda Armstrong units. Intrinsic semiconductors. Solar cell materials. Based on materials, solar cells divided into three generation cells. Second generation cells are the thin film solar cells, which include amorphous silicon, cadmium telluride, and copper, indium, gallium selenide. Third generation solar cells are made up of organometallic compounds and inorganic substances. Up to now, they have to not come into market. Hall effect in semiconductors. Polar dielectrics are those in which the possibility of center coinciding of the positive as well as negative charge is almost zero. That is, they don't coincide with each other. The reason behind this is the shape, and they are all asymmetric shape. Some of the examples of polar dielectrics is NH3, HCl, water, non-polar dielectrics. In case of non-polar dielectrics, the centers of both positive as well as negative charges coincide. Dipole moment of each molecule in non-polarization is zero. All these molecules which belong to this category are symmetric in nature. Examples of non-polar dielectrics are methane, benzene, etc. Ferroelectricity, BaTiO3, Rochelle salt, potassium dihydrogen phosphate, potassium niobate.